You guys can hear me now, right? You guys can hear me well now, right? Hey, you can hear still? Yeah. Yashmo hota, you can hear me now, right? But with 4 viewers, I wouldn't be doing anything. Oh, 9 viewers. That's nice. All of you are subscribed, right? We need 10 viewers at least to start. Okay. Let me share this link in the group. Oh, hope I don't lose you. Please stay. I want you, I need you, oh God. No. Till then, I'll play songs for you people. But then it says plagiarism and such shit. Mm, 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 mm. Not having any nice songs. Oh, 19 viewers. Damn. Too many people. Too many people. Just wanted to know we will solve all questions, right? I don't know, Aditya. We may not solve some, we may solve all. I don't know. So, nice thumbnail. 20 viewers, that's a lot. I feel pressure. I cannot do anything. I have to drink water. I should have washed face at least, I think. So, what's review like? Was able to solve A, B, C1, D, E. Don't know was how wasn't able to solve C2. Okay, people. Okay, let me open the. Let me share screen then. We will decide. So, if you people see this thing, I haven't entered it yet. Okay, because problem solving is same. I tell you people every single time how to solve problems, but still you don't solve. Oh, my next contest is August 28th, it seems. Hope I'll do better then. Uh, so I'm still saying the same things again every stream. Okay, every stream I say the same things. That is purple. This is not purple. That means I haven't yet opened it yet. Okay. Don't expose me someday like telling, oh, he's a fraud. He uses ChatGPT in the down and then solves the problem in general. Don't do that in future. Okay. So we have problems. If you see solves, F has 700, so doable. G is 166, probably doable. E, D, these things. Okay. Uh, has anyone solved only till D then? Then I'll go for D was, what do you, lag? Fuck, lag. Solve G. Why do you find challenging more? JE advanced preparation or CP? Bro, ask relevant question. Okay. Most of you have solved till D, right? What should I start for? So let me read G and then come back. Let me read G. I don't solve it. I want 40 fucking viewers. Damn. I'm famous at this point. Guys, whoever 40 viewers are, if you guys are not retarded and if you guys can hear me, like the video. Okay. It doesn't take long if you can move your fingers. Okay. All of you must like the video. I hope you guys can do that. First, like the video. So, first, I will read G and then I come back. I'll just read G from A. Okay, can you guys hear me? Hear me? With no lag, I suppose. Screen not visible. Fuck! I've been sharing screen. From how long is screen not visible? Okay, okay, fine. So, like the video two people, so let's try to read some problem. Let me read D, C1, C2. And then I'll try to say the difference between C1 and C2. I will go to B2 because someone asked me for implementation, right? No, I will do random order. I will do random order. Let me read D. Let me read D and then come back to below. I will read all. I will read all. Like, guys, D should not be difficult. So follow me. Oh, this seems small. From 1 to infinity. Vadmin, Vadim wanted to understand the infinite sequence of digits that consists of positive integers written consecutively. 1, 2, 3. Okay, we have this sequence. To avoid looking into infinity, Vadim cut this sequence at kth digit and discarded everything after it. So he has cut it after kth digit and discarded. Not the. So this seems shitty. We have some shitty sequence. At k we have to break. This wouldn't have much logic, right? This would be trying to find what was that number. We can binary search somehow. We can know what was the number that ends at k, right? What k, whatever the number that comes just after k or that intersects with k. So we can binary search that number. After you binary search that number, it's just number of one still there, number of two still there, number of three still there. It doesn't feel interesting. It doesn't feel that good. That good. So we have a shitty problem at D. So let me read C1 or C2. Fine. I hope this is a better problem. This is definitely annoying. Like, not too annoying. See, if you make things clear, annoying. It will not be too difficult. If you make things clear, if you make steps clear, it would not be too difficult. Maybe you can find some pattern. Maybe you can think of some pattern and then maybe you can somehow make it work. Okay. Because we want sum of the digits. Sum of the digits. We want sum of the digits, right? Sum of the digits till one number is not that difficult. Sum of the digits still not till one number. There is some permutations and combinations too, I guess. Not permutations and combinations. That's not that difficult. Some of the digits till this number is not that difficult. You can somehow count it. So this is not that difficult of a problem. Maybe you might have thought this is difficult. So whoever has not solved D, it is having very less logic. First you will find that number and then you will try to find sum of digits in 1 to n. If you are given 1 and n, you need to find sum of digits in that. Both of them are not that difficult. So this has less logic. Maybe C1 has more logic. Maybe C1 or C2 is good. Let me read C1 and C2. I hope viewers don't drop because I need energy to talk. The holy waters watered down. Can you guys see my screen? Is it being fine now? You can keep something Hitachi. High. High is not that difficult. You can keep something. Right. Holy waters watered down. Okay, let's read C1. Okay, see, what I have done was I have read D. I considered it like it's not being that good, so I'm reading C1 and C2. Okay, So guys, I'm about to reach C1. Subscribe, like, don't be a retard. I'm asking you, just do that. I know you subscribe to many shitty things online, so just subscribe to my thing too. Problem C1 I'm reading. This is the easy version of the problem. The easy version differs from the hard one in that it requires determining the minimum cost with the least number of deals, while the hard version requires determining the minimum cost with the limited number of deals. What the fuck is that? uh, Determining the least minimum cost with the least number of deals. Uh, Let me read the problem too. Okay, the easy version differs by determining the okay the fuck they're complexing. They're using complex statements. A girl couldn't understand this statement, I think. So what they mean is hard one requires finding minimum cost with the least number of deals, while the no, I am a girl. I'm not understanding things. Sorry. Hard version requires determining. Fuck, I'm not understanding it. Okay, let's read the problem. After the watermelons, one instead of one, he decided his profit. Sold three watermelons. Now he can sell 3 power x watermelons for coins, where x is a non-negative integer. A calculating buyer, I didn't understand whatever the shit it was, but let me read the next line. A calculating buyer came to him, but he has critically little time. Why the fuck are these problems like this scary? Because of this, he wants n watermelons, making the least possible number of deals. Okay, the buyer is in a hurry and has therefore turned to you for determining the minimum number of coins he must pay the seller for n watermelons, considering that. So now, what is this? Where x is a non-negative. The cunning seller sold three watermelons instead of one. He decided to increase his profit. Namely, he bought even more watermelons. Now he can sell 3 power x watermelons for 3 power x plus x times 3 power x minus 1 coins. What the fuck does that mean? I don't see any cunningness here. I don't see whatever the shit is to what it is. X is a non-negative integer. Such a sale is called a deal. So he can only do deals where he will sell some 3 power x watermelons for some amount of coins where x is a non-negative integers. So I don't know what's coming here, but then he can sell 3 power x watermelons at a time for some amount of cost. He can sell either one watermelon or three watermelons or three square watermelons up to so on. That's what we understand, right? Now calculating buyer came to him, but he has critically little time. Because of this, he wants to buy n watermelons, making the least possible number of deals. So he wants to buy n watermelons, and then he wants to make least number of deals. Okay. The buyer is in a hurry and has therefore turned to you, determining the minimum number of coins he must pay the seller for n watermelons, considering that he will make the least possible number of deals. Okay. Till here it seems fine. It seems okay, right? And it seems a bit direct too. Let me read C2. The buyer is in a hurry, making the least possible number of deals, and then what's the difference here? The buyer is in a hurry and therefore has told you to determine the minimum number of coins he must pay the seller for n watermelons if he makes no more than k deals. Okay, here, okay, here it's a bit more restricting too. Previously, we don't have any restriction on number of deals. We can take more deals and then pay less amount. But then here we have a restriction on K deals. Sounds shitty again. So there is something not shitty. Sounds like it's something great or too difficult, right? It somehow sounds like too difficult. But maybe there is something that makes things very simple. Maybe there is something that makes this very simple. There should be. Otherwise, how the fuck can we find something like how can you prove something uh, like number of deals is fixed, so without exceeding these many number of deals when k is a very big number, it's a bit difficult, right? So we have n comma k, we have only n here. So let's think of the problem a bit. Okay, damn, I'll just check my subscribers because My next streams onwards, I will just keep only for subscribers. I'll only keep. I'm just joking. 751. No one wants positive delta now. Did I say D is DP? Okay. For D topic tag is DP. How to apply DP further? Hitachi, they just keep random tags. Don't care about that. Guys, coin greedy problem. There are no problems. Just solve this. Let's just try to solve this problem for what it is. Okay. Let's just try to solve this problem for what it is. We want some number of deals. Okay. So at each step we get 3 power x watermelons, right? If 2 power x, if it is just 2 power x itself, that means greedy works. If it is less than 2 power x, greedy may not work. 2 power x has the specialty somehow, because for 2 power x, even if you take everything else, you cannot get as much as 2 power x. Wait, what am I doing? What am I telling? Yeah, just leave what I'm telling. So let's say we have to take 3 power x watermelons. One obvious thing we can do is see n in terms of binary representation of 3, and then just take those things, right? But then is that just the answer? I don't think that answer can be that simple. They say the holy water's watered down. So minimum number of deals you can do. Because if 3 power x is such a big number, you must take that, right? I have to prove to you people, okay? I think that's it. We have to see, but not binary, we have to see ternary representation of n. So let's assume we don't know anything. We don't know that greedy works or anything works, okay? But let's say we are taking 4 3 power x. Somewhere we are taking 3 in the optimal, finally. In the optimal, finally, let's say you're taking 1 2 power 0, 2 3 power 0. At somewhere you're taking 3 greater than or equals to 3 power x, up to so on. But if this is the optimal, what can you do? Instead of taking 3 power x, you will just keep everything else same, and then you will just make it, instead of having 3 power greater than or equals to 3 power x, y greater than or equals to 3 power x, you will just keep y minus 3 here, 3 power x, comma 1 plus, let's say we have z 3 power x plus 1. 1 plus z 3 power x plus 1. You will make it like that. Reducing the optimal. What we have done? We have reduced the optimal, because here it was 1 plus 2 up to so on, y plus z number of deals. But now it is y minus 3 plus 1 plus z number of deals. We reduce number of deals, which says in optimal, you cannot have anything greater than or equals to 3, which says we must look at ternary representation of n, and just do that many deals for all x. So till here it seems simple. And whatever the fuck did this? 3 power x plus 1 plus x times 3 power x minus 1. 3 power x plus 1 plus x times 3 power x minus 1. Right. When x is 0, this is 0. That seems fine. So let's just do that. 10 is greater than or equals to 9, right? 9 is 3 square. 9 2s are 8. What about 3? 1 2 3 4 5 8 9. 3 power 20 seems fine. So let's there, because we cannot take 3 power 20, right? So before that, bit x equals to n reminder 3, and then we have n by equals to 2. What's the cost? Cx power x, right? Let's just have 3 power x. We have 3 power x in B3. P3 has 3 power x. So answer is Cx is 3 times, they say the holy one is 3 times P3. P3 is 3 power x, okay, plus x times P3 by 3. And then I'll multiply P3 to 3 so that it will have that. Say the holy one is for. So this was the cost. And then why Cx times Bx? Cx is the cost, and then we have to do Bx number of things, right? Because if 2 was the final thing in the bit in the, we have to take 2 power ones. If you are taking x tills Bx number of times, then this is the answer. So till here, this problem is nothing. This should be direct. So this is direct. This is very direct. Anyone can make a guess because it's direct. Anyone can just do that. So this is simple. C3, C1. So is anyone not able to solve C1? I don't think so. Unless you guys haven't read the problem, I don't think you people would not have solved this problem. Okay. Say the holy waters water down. What's wrong here? Ah, that was random. So this, so if anyone hasn't solved C1, that means done anything. I mean, that means they haven't read the problem probably, right? So let's go for C2. It's 24 minutes already. Oh my love, oh, taking me out the ordinary. Yeah, I can see this shit now. Well, so what has been done is C1 has been done, okay. Obvious, C1 was very obvious, but still I was just trying to prove some optimal techniques because we may use those same techniques better. What's one way you can prove? You can prove that greedy works, but you can also prove like if there is finally, let's say this was the optimal way you have taken, like 1 3 power 0, 2 2 power 2 3 power 1, up to so on. If something is greater than or equals to y, you can say greater than or equals to 3, you can't say you can reduce number of operations. So that means in the optimal, you cannot have anything greater than or equals to 3. And then if you can say that everything is less than 3, there is a unique way. And then you can, that unique way must be equals to uh, 3's by thing. You can prove that later. I have proved that in my life really that, okay, if all BIs are less than 3, is there a unique way? I have really done that. Because how I have done that? Subtract those two things. Subtract two different things. You can notice that everything is 3 multiple. These two things are reminders, so they must have been equal, and then divide by 3, and then you can check other two things too, and then they must be equal. So that thing I have proved long back. You guys should prove such every simple thing you have to prove in math to learn more theory, okay. I hope you guys were able to follow what I have told. But now, yeah, now this was direct, so let me read C2. I hope this works. I hope this works. They're not even giving me a hike at Apple. That's why I'm doing streams. Guys, is the lag gone or is it still there? I don't know what to do. Sometimes it happens. Bro, I have a good number of views on Division 3 streams, but then this shit is happening. You say the holy waters watered down. You guys can see the screen, right? Can you guys see screen? Can you guys hear me? Yash Mahota, can you see my screen? Yash, can you see my screen and can you hear me properly? Say the holy word is watered down. It's very good. Right. Yeah, so now let's try to try C3. Okay. Let's try to try C3. I have made things work somehow. So now let's try C3. Say the holy word is watered down. Guys, don't waste time. I hope it works out somehow. Let's try C2. Let's try E. Let's try C2. Okay. So for C2, let's try to see what we can do. We have to find, we can only do K deals, it seems. We are restricted with the number of deals we can do. And that K can be any large. We know we can do in at max 2 times 20 deals. Right. We can do in at max 40 deals. Right. So K greater than 40 is useless. So guys, so now we have this thing. Okay. So now we are restricted that we cannot take more than this number of deals. But then, exactly, and he has to buy exactly, and wait, isn't it the same problem? I don't get how this one differs to the previous one. Believe this. So, so what is Cx? 3 power x plus 1 plus x times 3 power x minus 1. This thing matters now, right? The thing matters because if this cost matters now. We have to minimize cost. Before we wanted to minimize number of deals. Now number of deals has some restriction, but we have to minimize cost. Previously it was not at all about right. So let's again see. It's optimal. Then what can we say? Say the holy word is word. To minimize cost, what can we say about minimizing cost? What is this function Cx? Is it greedy? Again, like before, let's say we have 0, B0, B1, B2 up to so on, BL up to so on. Okay. Now, if we have uh, y 3 power x and z 3 power x plus 1 and so on. Okay. What is the cost of this? Y times Cx plus Z times Cx plus 1. Right. The thing is, maybe now we cannot guarantee that y being less than this is optimal. Right. Maybe we cannot now say that y being less than 3 is the best we can do because previously we were able to say that. Now We have to see these things clearly. So, how quickly would this rise? Right? How quickly would this Cx and Cx plus 1 will rise? We want to see that now. Right? Because when you, if y is less greater than or equals to 3, you can always make minus 3 times Cx plus z plus 1 times Cx plus 1. Right? But what do we want? Cx plus 1, we want it to be less than 0. When y became, how much screen is visible? So guys, so see, if these weights increase drastically, previously it was y plus z, right? 2, if y, suppose let's say y can be greater than or equals 3 or not. What does that mean? Y minus 3 times cx plus, this is what you can do. I'm again trying to apply the same thing that I have done here. I'm trying to apply the same thing. I'm trying to apply the same thing. So what do we want? We want this new cost to be less than or equals to previous cost. What is new cost? Cx plus 1 minus 3cx less than or equals to previous one, which is 0. I'm subtracting this one on both sides. Okay. That means we want, if we can proceed like this, we want this to be less than or equals to 3x. And does that happen always? Because Cx has x plus 1 coming up. So this never happens. So we cannot use this logic. Okay. We cannot use this logic. Right? We cannot use this logic. Hello. So I'm trying to equals to 3. Okay. We can move that to, see, we have to see these things finally, because we have to guarantee that These things will add up to n, right? So we have to see these things. And then I'm telling, let's say we have y greater than or equals to 3. Then if you see, doing this is good or not. To see that, once you do this, the cost should reduce. But this is false because x plus 1 increases, right? Cx plus 1 is, I mean, we can see this is wrong because Cx plus 1, we are additionally having a 3 and then we are additionally having plus 1. So this is false. So let me see these two things. Okay, let me see these two things. Let me see what happens when you move three things there. Okay, what happens? What is Cx plus 1? Because this just says taking once is optimal. This means taking once is optimal, but I don't get that. How can taking once is optimal? See, this thing is never is always false. Means we have Cx plus 1 greater than 3Cx. Means instead of moving three things right side, moving one thing left side is good. Because if it is opposite, what is better? If you have 1 3x plus 1 and y 3x 3 power x, then what does that mean? Making it 5 plus 3 3 power x plus z minus 1 3 power x is optimal. So it got reversed now. Before going like this is optimal, now coming like this is optimal. Before pushing everything like this is optimal, now pushing everything like this is optimal. So what do they mean by this is costs are increasing thrice. So coming like this is optimal. That's what it means. Trying to push everything like this is optimal is what it means. Okay. Trying to push everything like this is optimal is what they mean. But then taking everything zero, is that optimal? I don't get it. Okay, now we have K. Now we have fucking K. Right? Now we have K. Now K will help here. Push everything this side. Okay. So it means, so now we have to think. So now we have to think. So if you remove one here and then add two here, that means Sometimes it's impossible. See how deals changes when you do z minus 1 and y plus 3, you have increased two deals, right? And taking biggest z is always good. Now if you see this thing, when that goes here, it's like plus 2, right? When you move that here, you increase number of deals by 2. Leftward, you increase by 2. Okay, moving z is good. So is it just moving things from highest z? Is that it? Move as many as you can from this. See, here, first step is clear. And when you know first step, you can proceed further. As simple as an algorithm can get. It's not even greedy. I mean, yeah, it's greedy. See, all of these are like equivalent in some way. You have this thing, you can move things here. So they must add up to n, right? That's fixed already. So if you take binary ternary representation, moving things this side, moving them this side, all of them are like almost equivalent. So if you have this thing, always moving this is, it's like greedy now. It's like greedy, trying to move as many things as you can. Move, 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 move. That's it. Okay. So now let's do that then. Say the holy waters water down. Guys, was it working? I don't think we can prove that. I can see a clear proof here. Okay. Start from here. Whenever you can move the highest, I mean, I was able to see a proof in my thing. Right. Let's start with, I don't know why am I starting with the minimum. Why am I starting with minimum? I understand what you're telling, but then see, So let's try to look at let's try to look at things can't be that vague, and if they were, we can't solve problems. Okay, that's a complex statement to make. So, what is that? Having minimum, you cannot have such vague proofs or vague ideas. Fuck. All we got is falling out.